Hello students, in this video we will discuss the remaining topics of classical relation, that is operations on classical relation, properties and composition of the relation. These are the operations defined on a classical relation. First one is union, which is represented using this particular symbol R union S, where R is one relation and S is the another relation. So R union S will return the maximum from the relation R and the relation S for any particular ordered pairs, and intersection will return the minimum ordered pair from the relation R as well as from the relation S. Which one is minimum, that will be returned for intersection. Next is complement, that is 1 minus psi of R of x comma y, and the containment means if R is a subset of S, which represents psi of R of x comma y will be less than or equal to psi of S of x comma y, and the last operation is an identity operation. These are the properties defined on a classical relation: commutativity, associativity, distributivity, involution, idempotency, law of exclusive middle, that is excluded middle law, and De Morgan's law. Next is composition of classical relations. Composition means, suppose we have two binary relations. Let us say we have a binary relation S and we have another binary relation R. We are performing some operations on this S as well as on the R to get a single binary relation. This is called composition. That means some operations are executed on two binary relations to get a single relation. Let us say we have the relation R and this maps from elements from x to y. That means R is a relation taken from the set x and y. Now we have another relation S which maps elements from y to z. That means the ordered pair elements in S are taken from y to z. So we can say that since R is taken from x and y, R will be a subset of x cross y and S will be a subset of y cross z, and the composition between the two relations is denoted by R composition S. Let us understand this through an example. We have one set X with elements A1, A2, A3 and another set Y with B1, B2, B3. Next Z with C1, C2 and C3. Let us define a relation R. This relation R, we are taking it from X and Y. Okay. So we can make ordered pairs with A1, A2, A3, B1, B2, B3. We are defining some particular ordered pairs A1, B1. Okay. From X and Y. A1, B1. Then A1, B2. A1, B2. Next is A2, B2. And another one is A3, B3. These are the ordered pairs that we are included in relation R. That means it is a subset of the Cartesian product X cross Y. Now for the relation S, we are defining some elements B1, C1, that is from Y and Z, B2, C3 and B3, C2. Now let us see how we are going to define composition of these relations, that is R composition S. Okay. Observe this, we have A1, B1 here, and in S we have an ordered pair B1, C1. So we can make a relation from A1 to C1. Since we have A1, B1 and B1, C1, we can make a relation from A1, C1. Okay, so this ordered pair will be included in our composition S. Now check for the other pair A1, B1. Okay, no other pairs we can write. Now we are taking A1 and B2. And here in S we have one B2 and C3. So we can correlate or relate A1 and C3, which is written over here. Now A2 and B2. And we have B2 and C3 in S. So we can write A2 and C3. A2, B2, B2 and C3. So we can write A2 and C3. Next is A3 and B3, and we have B3 and C2. So we can take the relation A3 and C2. This is the composition of R and S. Okay, say this R. What all relations are included in R? A1 B1, A1 B2, A2 B2, A3 B3, which is represented here. A1 B1, A2 B2, A2 B2 and A3 B3. Now for S, B1 C1, B2 C3, B1 and C1, B2 and C3, B3 and C2, B3 and C2. By observing this mapping, we can find out our composition S. See, A1 is having to B1 and B1 is mapped to C1. So in our composition S, we can take A1 and C1. Okay. Similarly, A1 and C3. Then A2 and C3. A3 and C2. Okay. This is our composition S. And these are some of the properties of composition operation. Associative, that means R composition S, composition M is equal to R composition S composition M, and commutative means R composition S equal to S composition R, and inverse R composition S, the whole inverse equal to S inverse composition R inverse. Thank you.